Okay, so this is Mr. G, and I'm going to work these problems here. This is your physics problem set 3.1. And so here we go. Question 1. I'm going to toss a ball straight up in the air, and it begins slowing down at a rate of 10 meters per second. If it starts with a speed of 30 meters per second, how long does it take before it stops moving up? So I'm going to draw a picture first, which is not necessarily, strictly speaking, necessary, but what the heck. I love drawing pictures. So here's your little ball. That arrow represents its initial upward velocity. And I'm going to write some things down. It starts with a speed of 30 meters per second, the starting speed. That tells me that V naught is equal to 30 meters per second. It also says that it starts to slow down at a rate of 10 meters per second per second. That's the acceleration. And because in this case, the acceleration, remember, an object that is in free fall has an acceleration of about 10 meters per second downward towards the Earth. In this case, I've already set up my coordinate system by saying that its initial velocity is plus 30 meters per second. So positive is upward, down is negative direction. So I really need to write that A is about minus 10 meters per second squared. In other words, it's going to lose 10 meters per second of speed. Every second, it's moving upward. Okay. So then how long does it take before it stops moving up? In other words, how long does it take to reach its maximum position right here, and then it stops momentarily? So a couple of ways to look at this. One, if you start off at 30 meters per second, and you're losing 10 meters per second, it's going to take you 3 seconds to stop, right? Yeah, it's going to end up being 3 seconds. But if you want to, we could use our handy dandy little equation that I know so many of you like to use. So that equation would be V final is equal to V naught plus A times T. And so, well, what do we, oh, I didn't put what V final is. If it stops moving up, that means that V final is 0. And here I'm looking initially for T. Right? How long does it take? That's time. So, yeah, I'm going to use algebra. I know you like to plug the numbers in first, but trust me, it's going to be better in the long run to learn how to rearrange this expression in variables and then plug the numbers in the last thing. So to get that T by itself here, oh, wait a second, that V final is 0. It stops moving, so that's 0. So get away with that. So the first thing to do to get T by itself is I'm going to subtract V naught from both sides. So I have minus V naught and minus V naught. And then this is undoing the algebra that's been done here to get this equation. So yeah, V naught minus V naught is 0. So on the right side, I just have AT left. And on the other side, I've got minus V naught. And now to get the T by itself, divide both sides by A. Algebra. The A over A cancels. Cancel culture. And so I've got that t is minus v naught over a. So now I can plug some numbers in. So v naught was 30 meters per second. And the acceleration, we said, because in this case it's accelerating downwards the negative direction, so the acceleration is minus 10 meters per second, which can be expressed as meters per second squared. Okay, so minus 30 divided by minus 10. The minuses cancel each other out. I end up with basically 30 over 10, which is 3. And the dimensions are, so a meter per second divided by a meter per second squared. So meters cancels, one of these seconds cancel, and this little guy, which is way downstairs, comes back upstairs. Yeah, so all of that was the equivalent of, again, just realizing if you're initially going 30 meters per second, but you're losing 10 meters per second of speed every second, it'll take you 3 seconds to get back down to 0. Next, how high does it go? That's like delta x. It's going to turn out to be delta y, but that's okay. So delta, new iPad. So delta x is this displacement right here. So there are, again, a couple of ways to figure out what that delta x is. I'll show you 2 ways. One way is that delta x is just v average times t. That's always going to work. Yikes, but wait, I don't know what v average is. Well, yeah, you do know what v average is. It started off with a speed of 30 meters per second. It ended up with a speed of 0 at the very highest point. What is the average of 30 and 0? How do you find the average of 2 numbers? Well, you add them and divide by 2. Or the average of 30 and 0 is the number that's right in between the 2. It's 15 meters per second. All right, so now I can do, so down that, now the height it ends up going. So the average speed is 15 meters per second. Times 3 seconds. So let's see. The number part is fairly straightforward. 15 times 3 is 45. And here I've got a meter per second times a second. The seconds cancel. So yeah, it's going to go up in the air 45 meters. That's its highest position. Another way to get this exact same answer would be to use this equation. How about delta x is v naught times t plus 1/2 a t squared. All right, so let's see how this is going to work here. So delta x is equal to, so v naught was 30 meters per second. Times, the time was 3 seconds. Plus 1/2, in this problem, the acceleration is minus 10, about meters per second squared, times t squared, so times 3 seconds squared. Oh my gosh, numbers. 30 times 3 is 90. And meters over seconds times seconds. That just leaves you with meters. Plus 1/2 of -10 is -5. Meters over second squared times 3 squared is 9, and it's seconds squared. Now those second squareds cancel out here. Bloop and bloop. -9 times 5 is -45 meters. So our answer is 90 meters minus 45 meters. Ooh, that's 45 meters. That's how high the ball goes until it stops, which was the same answer we got over here using this method. So that works out. Physics is pretty consistent. All right. Okay, that's good for problem number 1. I'll go ahead and stop that right now and upload it.